Hello, math friends. Welcome to A Squared Math and Stuff. In this lesson, we are going to take a look at an introduction to limits. And with this introduction, we're actually going to look at the table method on how exactly we approach a limit and what exactly a limit is. So the first thing I want to do is read the official definition of what a limit is. Then we're going to do an example because you're not going to understand anything that I say with the definition. Then we'll do the example, and then we'll come back to the definition and try and put it back together a little bit to have it make a little bit more sense to you. So, the official definition says if f of x becomes arbitrarily close to a unique number L as x approaches c from either side, then the limit of f of x as x approaches c is L. This is written as the limit as x approaches c of f of x equals L. Yeah, probably didn't make sense to you, did it? That's okay. We're going to do an example down here, but before I do that, I do want to write out how you say this notation here. It's really hard to see in the video, but there's actually an arrowhead right there. Can you see that? Let's see if I can focus that for you. There's a little arrowhead. It says x approaches c, and the arrowhead's pointing towards the c. So let me write that whole statement down and what it says. The limit as x approaches c of f of x is equal to L. So the limit as x approaches c of f of x is equal to L. Let's take a look at an example so we can start talking about exactly what this means, because I guarantee it still doesn't make any sense to you. Okie dokie. First example. We are going to take a look at the limit as x approaches 2. So in this C position, we have a number. C stands for constant. So we're looking at as x gets closer and closer and closer to the number 2. In this equation, 5x plus 4. In the table, we have our value that we are getting closer to, our C value, is going to be in the middle here. And we need to figure out what this value is. So this table method is very, very useful because not every single equation is solvable. So sometimes you have that 0 in a denominator, and you get undefined when you have that 0 in the denominator. But if we look at limits, that allows us to figure out a number that we get so close to that we could say as the limit, or as we approach that number, it gets closer and closer to equaling this other y value. In this equation here, we have a straight line. It's a linear equation, 5x plus 4. We could graph this, we could calculate this. So let's think about it. If we plug in 2, because I'm saying x equals 2, if I plug in 2 here, I have 5 times 2 plus 4. Well, 5 times 2 is 10 plus 4. We're looking at 14. If x equals 2, then y equals 14. This is kind of the idea of the limit. And you'll see that the y value at 2 is actually going to equal 14. That's because we have a straight line here, but it's not always going to equal a number. You'll see that in our next equation. All right. In this table, I'm giving you values, and these values are getting arbitrarily close or infinitely close to our C value, that number that we want to get closer to. So if we look at this, I am going to add 1 1/1000th to 2. I'm going to subtract 1,000th from 2. So that's where these two numbers come from. I'm also going to add 100th, and I'm going to subtract 100th. And then finally, I'm going to add a 10th and subtract a 10th. These thousandths, hundredths, and tenths become very important, and we'll do that in our next example because we'll have to fill this out. So stay tuned for example 2 if you don't understand what's going on here. All right, when we have a table, we can just use our calculator. So let's go ahead and do that. I don't have a nice fancy new colored screen, so I apologize about that, but we will make this work. So let's go ahead and go into y equals. We're going to enter this equation, 5x plus 4. And if we graph that, you'll see that it's a straight line, just like we talked about. It's a linear equation. But what I want to do is I want to take a look at the table. And in the table, I want to quickly be able to tell what these values are so I can fill this table in. Well, right now, I only have whole numbers here. I need decimals. So let's go ahead and change it so I can tell the calculator what to calculate for me. So I want you to go into second table set, so second window, and we are going to go through the independent. Your independent is probably set to auto right now. I want you to arrow down and change that to ask. So once you have ask highlighted, hit enter. And then we're going to exit out of this and we're going to go back into the table. So second table. You'll see that your table is cleared out right now, and I can tell it what I want it to calculate, what x value to calculate. So I'm first going to plug in 1.9. So type 1.9, hit enter, and it will tell you what your x equals. So the x here is 13.5. Now let's tell it to calculate 1.99. We'll see that it's 13.95. Now let's tell it to calculate 1.999, and that becomes 13.995. Skipping over the 2, we're going to plug in 2.001, and we see that it equals 14.05 or 005, and continue on. 2.01, we get 14.05, and finally 2.1, we get 14.5. The limit says if I come in from the left-hand side, or the numbers that are lower than my C value, the numbers that are lower are here. So this is our left-hand side. And as I come in from the right-hand side, or the numbers on the positive side, or that are larger than our C value, if these values are getting closer and closer and closer and closer to the same number, then we have a limit. So we're going to get closer and closer and closer to our C value of 2 because we're only a thousandths away. We're pretty darn close to the number 2, but we're not touching 2. We are not at x equals 2 quite yet. But what we can see is this number is getting stinking close to 14. This number, super duper close to 14. So taking a look at these, we can say that x, or our y value, f of x, is approaching 14. So our limit as x approaches 2 of 5x plus 4 is equal to 14. And that's the exact value we got when we plugged in 2 into this linear equation. And again, you can only plug this into the this way because it's a linear equation. This next example, on example 2, if you plug in our C value, we're going to get 0 over 0. So it's not a number that we can instantly calculate through plug and chug. All right, so coming back up to the definition, let's take a look at that. Let's see if it makes a little bit more sense. It doesn't need to make 100% sense because you still need to practice. But if f of x becomes arbitrarily close. Arbitrarily close, we did that. We were getting super close to our c value, our number 2. So if f of x becomes arbitrarily close to a unique number L, in this case, our L ended up being 14. So again, as f of x becomes arbitrarily close to a unique number L as x approaches c from either side meaning that left-hand side, we went smaller, and the right-hand side, we looked at numbers that were bigger. Then the limit of f of x as x approaches c is L. And so we found that our limit is 14. Please take a look at example number 2 in the next video, and there'll be further explanation, and we're actually going to come up with these numbers on our own. They won't be given to us. So check that out. If you like what you saw, hit the subscribe button, and I'll be chatting with you soon.